Hello there. A huge thank you to Mazowiecki program stypendialny. It's because of them that I'm able to show you how I calculated the solubility of the following salts: potassium carbonate, sodium carbonate, and lithium carbonate. I decided to choose these salts because they were the ones that my school had in stock at that moment, and because they were fairly cheap. They happen to be from the same group, which you can see by looking at their molecular formula too. I also chose them so that the results would not be exactly the same. Some salts were harder to dissolve and some were easier. I dissolved the above stated salts in 3 varying temperatures: room temperature, 40 degrees, and 80 degrees Celsius. During the video, I'll guide you through my process of learning how to work in a laboratory, tell you about the mistakes I made and how I fixed them. In the end, I'll show you the results. If English doesn't happen to be your native language, I have versions of this video in Polish, German, and Russian if that suits you. I started off by weighing the first salt, sodium carbonate, exactly 2 grams. After measuring that, I put the salt in the beaker. I labeled each one so as to not get confused which one's which. And here is all of the measured out salts. I'm doing 3 different salts and 5 probes for each salt. After that, I proceed to pour distilled water into a vessel made for measuring fluid and fill it up to 50 milliliters. Then, slowly, drop by drop, I pour the dihydrogen monoxide in, whilst mixing it with the salt. And the final result. Then I did the same for lithium carbonate, by first measuring the weight, but this time I was a tiny bit off. I then put the salt in a beaker, mixing it again with distilled water, 2 down, 1 to go. What's left is only potassium carbonate. As usual, I first weighed the salt and then mixed it with water. Of course, I did all of this while taking notes. As usual, I weighed my salt. Then I poured exactly 20 milliliters into a measurement cylinder. And noted the things I had done. Then, with the 20 milliliters in my vessels, I put them in a heater. It is then that I realized I had made a mistake. The flask I had taken was incredibly buoyant. I thought about how to stabilize them, but then I promptly dismissed the problem. Moments later, off camera, my flask floated a bit too high up and ended up tilting over, and the contents of it splashed into the container. It is then that I decided to go with a safer choice that I had not considered earlier, using smaller flasks and less water, this time just 5 milliliters compared to the 20 that I started off with. While the water was still heating up, I took up the job of making filters for the rest of the salt that would not dissolve in the water. To make a filter, at first you have to make a square out of the paper and fold it 2 times, like so. And then fold it again, like so. I folded them up and put them on top of my flasks. Then, after a longer period of time, I mixed the salt for the last time really quickly so that the residue would not stay at the bottom of the tiny utensil, and poured it in through the filter. While mixing, you have to watch out as to not break those containers, as they are made out of very thin glass. I, unfortunately, managed to break one though. I did the same for every flask, and here is all of them. Of course, never forget to note these things down. I started as usual by weighing the salt. This time I added a bit more because the temperature will be higher and therefore more salt can be dissolved. But never forgetting to take notes. Then I put the utensils in the heater. And heated it up to 80 degrees. When heating up, the trick is to add a bit of boiling water to the tub so it can evenly distribute and boost the temperature. I added just a bit and my temperature jumped up by almost 20 degrees. When it was hot, I added salt to the utensils and took notes on how much salt I had added. After that, I measured 5 milliliters of water in 15 vessels. 1 water vessel for 1 salt vessel. When everything was ready and the water was of the right temperature, I added the water to the salt. After an eternity of waiting, I mixed the salts for the last time and filtered them. As earlier, I cut up the filter paper again for the next salts. I then measured the residue of the salts I had filtered the day before. To measure the residue, you must take the filtering paper, which by this time should be dry, unfold it and shove the dry salt on a scale and measure it, noting everything down. I did this for every flask. Because I was running low on time and my salts of the day were not yet dried, I decided to speed up the drying process with yet another heater. I also had to redo some of the experiments that had failed. and also clean up a bit after myself, as I had by that time made quite a huge mess. And now to show my final results. And now for my conclusion. I would like to show you my final results, and with those results came some knowledge that I would like to share with you. After finishing the project, here are some of the conclusions I have reached. 1. Salts in general, chemicals, can be barely distinguishable and yet have very much different properties. You can especially notice this when you have a container of one salt that is, to the naked eye, not different at all to the salt in the next container, and yet the first one dissolves in 20 milliliters of water, and the second one is worse at dissolving than a rock. Second, I also proved the well-known fact that the higher the temperature of the fluid we're dissolving something in, the better that thing can dissolve and the more it will dissolve. Although everything to a certain point. It is not possible to dissolve a kilogram of salt in a drop of water, even if the drop was 1,000,000,000 degrees hot. Third point, I also noticed that nothing is accurate. When filtering the salts, there are always a bit of salt residue left in the probe that didn't make it to the flask. Fourth, a lab work might look easy, and believe me, I thought it would be a piece of cake. Turns out that being concentrated for hours on end and not being able to take a break is not that easy. And if you happen to make a stupid mistake, it can cost you hours of hard work. Fifth and finally, labeling and being organized is key. As I stated earlier, some salts are indistinguishable from each other and yet be polar opposites of themselves when reacting with a substance. So labeling which container has what salt in it is a pretty good idea if you ask me. Before I finish, I would like to thank everybody that has made this video possible. First of all, my teacher, Ms. Ewa Barylska, who helped and assisted me throughout the project. Second, the school, who allowed me to use their lab, Liceum imienia Stefana Batorego in Warsaw. Third, Mazowiecki program stypendialny, without whom this project would never have come to fruition. Fourth, my mother, who told me about this project. And fifth, everyone who supported me and gave me constructive criticism. And I hope that you have gotten an insight as to how lab work is done and maybe even feel motivated to go and experiment for yourself. As for now, thank you for your attention.